So here we are with Chapter 10, Cloud Data Loss Prevention. Cloud Data Loss Prevention, or Cloud DLP, is a powerful service that helps organizations discover, classify, and protect sensitive data in their cloud environments. As businesses continue to move more workloads to the cloud, protecting sensitive information such as personally identifiable information, PII, payment card data, and healthcare information becomes increasingly critical. This chapter explores how Google Cloud's DLP service can help secure your data through comprehensive identification, transformation, and monitoring capabilities. Here's an overview of Cloud DLP. All right, and we'll get you to this page as well, which you can do by searching in the taskbar or, I believe, security data loss prevention. Cloud DLP offers a comprehensive set of features designed to help organizations protect their sensitive data. Cloud DLP's capabilities include 1. Detecting sensitive data. This is automatically scanning data across Google Cloud resources, including BigQuery datasets, cloud storage buckets, and data store, performing organization-wide folder-level or project-specific scanning, and identifying over 150 built-in sensitive data types. 2. Built-in information detectors. This includes comprehensive predefined detectors for common sensitive data types, an API-based architecture that enables rapid scanning, discovery, and classification. 3. Storage support. This includes native integration with cloud storage, data store, and BigQuery, and support for scanning structured and unstructured data. 4. Risk assessment. This includes calculated privacy risk levels through statistical analysis and evaluating K anonymity and I and L diversity to reassess re-identification risk. 5. Classification results. This includes sending findings directly to BigQuery for further analysis, and you can create custom reports using BigQuery and Data Studio. 6. Data security. This includes processing data in memory without persistent storage and regular third-party security audits for data confidentiality and privacy compliance. 7. Deployment and monitoring. This includes creating and deploying reusable inspection templates and setting up periodic scans with PubSub notifications for integration with serverless architectures. 8. Customization. This is defining custom information types and adjusting detection sensitivity levels. And you can also create specialized detection rules for your organization's unique requirements. So let's go into DLP's architecture options. Cloud DLP can be implemented in 3 main architectural patterns, each suited to different use cases and requirements. Okay, let me get. Okay, let's look this up. Inspection template, let's go there. And let's look for process flow. Not quite what I was looking for. All right, so process flow would be data is streamed directly to Cloud DLP APIs for inspection, classification, or transformation. Cloud DLP returns a synchronous response for immediate processing, and the client applications handle the response accordingly. Let me see. Let's get it good. Oh, that might have done it. We'll look for a good one. That might be a good image. All right, so we'll add these into the chat where you can look at these at your own convenience. That's an overflow. All right. The next one would be ideal use cases. All right. This includes data pipelines requiring real-time processing, interactive applications that need immediate feedback, and call center applications requiring immediate data validation. And then you have implementation steps. One, you would stream data payloads to Cloud DLP. Then you would include specific instructions on what to inspect, and then process returned inspection results. Next up, you have storage methods. All right. The storage method is designed for batch processing of data that already exists in Google Cloud storage devices. So what's the process flow? One, you configure jobs to scan data in cloud storage, BigQuery, or other repositories. Then Cloud DLP will automatically scan according to the defined schedule, and then results are published for further action, such as to Security Command Center. Ideal use cases would be regular compliance audits of stored data, periodic security checks of data repositories, and projects where you want to ensure no sensitive data is inadvertently stored. So your implementation steps would be to set up a job to scan for sensitive data, configure Cloud DLP to run the job on the schedule, and save and analyze the results. Then you have hybrid architecture. So hybrid architecture combines elements of both content and storage methods. Okay, the process of flow would be the following. You would create a workflow that sends data from any source to Cloud DLP. You would configure hybrid jobs, resources, or triggers to process the data. Then you would perform post-scan actions like saving results or sending notifications. Ideal use cases would be multi-cloud environments, on-premises data that needs cloud-based DLP processing, and complex workflows that require both real-time and batch processing. Common data sources would be other cloud providers like AWS or Azure, on-premises servers and databases, non-native storage systems, and web and mobile applications. So your implementation steps would be write a script or workflow to send data to Cloud DLP, configure appropriate job resources, and then set up a desired post-processing action. So let's go into some Cloud DLP terminology. So understanding this terminology used in Cloud DLP is essential for effective implementation and usage of the service. Info types. Info types are predefined or custom parameters that Cloud DLP uses to identify sensitive data. Cloud DLP concludes over 150 built-in info types covering various categories, like personal identifiers. That would be names, email addresses, phone numbers, social security numbers, and driver's license numbers. 2 would be credentials. This would be API keys, passwords, or authentication tokens. 3 would be financial information. This would be credit card numbers, bank account details, and tax IDs. 4 would be healthcare information. This would be medical record numbers, health insurance IDs, and patient IDs. And 5 would be location data. This is GPS coordinates, addresses, or postal codes. Each info type has an associated detector that identifies and processes findings during scans. Google regularly adds new info type detectors to expand the service's capabilities. So examples of common info type detectors include, let's see, look at you. And that was my books page. You always got to keep up, okay? So one example, advertising ID, right? So what is advertising ID? This will be mobile advertising identifiers like Google Play advertising IDs, right? Next would be credit card numbers. Right? So credit underscore card underscore number, right? This would be payment card information that follows common formats. So you could think the 4-4-4-4 digits. Then you would have your email addresses, right? So it'd be email underscore address. So this would be the standard email address, right? So, first at domain dot URI, okay? And then you would have US Social Security numbers, right? So that would be another form. And you would do this. This would be 9-digit SSNs, and it would go against specific validation rules. And then next would be your date of birth. Okay. So date underscore of underscore birth. So there'd be specific dates defined as birth dates. And it would validate against this, whether it's the 6-digit or the 8-digit version. All right. So the de-identification process is the process of removing or transforming personal information to protect privacy while maintaining data utility. Cloud DLP offers several de-identification methods. One, masking. So this will replace sensitive data with symbols like asterisks or hash marks, preserving the original length, but hiding the actual content. So here's an example of what you would do for a social security number, right? So that 1 2 3 4 5 6 7 8 9 would be 9 hashes, right? Another example would be replacement. So this will substitute sensitive data, whether a token or the info type name itself. So you can see here, the name lives at 123 Main Street would be replaced by person name lives at street address. Okay. Another one would be date shifting. So this will group data into broader categories, reducing specificity while maintaining utility for analysis. Right. So here's another example. Okay. All right. So original age 32, salary 87,432, but bucketed would be age at a range of 30 to 40, salary 80 to 90,000. Okay. Next, you have pseudonymization, right? This replaces identifying data with artificial identifiers or pseudonyms that maintain referential integrity. Cloud DLP supports 3 pseudonymization methods. One, deterministic encryption. This is DE, using AES SIV. So this would be strong encryption suitable for highly sensitive data. This preserves referential integrity, but not character set or length. And it's fully reversible for re-identification when needed. Next would be format preserving encryption, FPE, with FFX, right? This maintains the format, character set, and length of the original data, and is ideal for legacy systems requiring data-specific formats. And then it's fully reversible while minimizing changes to the data structure. And in 3, you have one-way tokenization using cryptographic hashing. So this creates a one-way transformation using HMAC SHA 256, and it maintains referential integrity without possibility of reversal. It's best for scenarios where re-identification is never required. So we'll go into creating DLP inspection templates. Inspection templates define what Cloud DLP should look for when scanning your data. These templates store your data classification requirements for reuse across jobs. And I think I included that already. But let's see if we can find that. Try this. We'll add this for the de-identification or re-identification. All right. And then we'll look for the template now. Okay. Oh, templates. Well, that's actually, that would be good for data flow. So how do you create a new template, an inspection template? All right, let's go in here. So we're at Cloud DLP. Now we're at sensitive data protection. Why isn't this letting me click on Cloud DLP? Let's cancel this. Sensitive data protection. I probably need the organization levels turned on. Yeah. Oh, that's okay. Inspection. Let's see if it's inspection. Great job and triggers. Don't see templates. So it'll take me to the certificate authority. Will it take me to the data loss prevention? Nope, only sensitive data. Oh. Okay. Let's see if I can find an overview of how to make this for you. List templates. That'll probably help. Here's a tutorial. Okay, that'll probably be the best bet. So I'll add this list templates. All right. And this has the information as well. Okay. And I'll include this in the list of links. but it's going to be done here. So you'd have to enable this, create an inspection template, configure the template, right? And so you can use this tutorial to do it. But essentially, go to the create menu, select template, click on create a new template, and then define the template. So that means enter an identifier using letters, numbers, and hyphens, and then provide a display name, and then add a description, right? And you configure detection to select info types to scan for. You can leave it blank to scan for all default info types, but you can add custom info types if you need, like words or phrases, dictionary paths, regular expressions, or stored info types, right? Then you configure the rule sets. So you'd add exclusion rules to eliminate false positives, create hot word rules to adjust likelihood based on context, and then set confidence thresholds for matching sensitivity. Then once that's done, you click create and you'd be good, right? So let's see if I can try this in the console, but I don't think it's going to be, yeah, it's not going to let me go unless I have access to it. But that was a good one. So you could technically do it in the CLI as well. Let's see if I can get this to open. Provision my shell, authorize it. Okay. So this code would let me do this. You see that cloud DLP inspect template, create, display name, my inspection template, description, location, global, and inspecting config is this is the inspect-config.json. And so that JSON would be named to define info types, the min likelihood, any other custom rules. All right. All right. So you can create de-identification templates. I don't think this is going to let me do. No. And that would be similar to the same effect, right? With the description name, the de-identifications, you could select the info type, the record or images, and then define how each info type should be transformed, either through masking, redaction, or encryption, and you click create, right? And then you could also do that in the CLI with the following command: gcloud DLP de-identify dash templates create, and then you have the display name, right? And then you have the description. If the location is global, and you have the de-identify did-config.json, and then you'd have that set there to define the de-identification transformations. All right. All right. So best practices for inspecting sensitive data. Effective implementation of Cloud DLP requires careful planning and optimization. One, you have to prioritize scanning. Focus your initial scanning efforts on data that poses the highest risk. This will be frequently accessed data, widely accessible repositories, and datasets with unknown content. Then you want to reduce latency. You can optimize scans performances by enabling sampling for large datasets, selecting only necessary info types, avoiding resource-intensive info types like person name or location unless specifically needed, and you can organize data into tables with clear rows and columns. 3, you want to limit initial scope. So start with a controlled scanning environment. Begin with a limited subset of data, then fine-tune detectors before scaling up. And avoid enabling all info types simultaneously to prevent excessive false positives. 4, you inspect the sample data, right? So for large data sets, you need to scan a representative sample first, then analyze the results and refine the settings, and finally, scale up gradually to the full data set. And 5, handle external data. For data outside Google, use the content.inspect and content.deidentify API methods. This will help you process data without transferring it to Google Cloud Storage. And you can implement appropriate encryption for data in transit. So let's see if we can go to the sensitive data protection jobs page. It's not letting me go here. I think we had it. Inspection. So this is to okay. Product coverage, enable. Let's discard that. Scan configurations. Yeah. Okay, so the inspection. So here's an inspection, right? So you create a job trigger. All right. So here you create the job ID, right? The region that it would go to. Okay. Then you check the storage type. Where is this going to be? Where is this stored? You know, Google Cloud Storage, BigQuery, Cloud Data Store, or your hybrid. Okay. And then you'd configure the detection. Okay, let's do data store. You can do the project ID. Let's see. These. All right. Kind. Continue. Data store kind. Oh, cloud storage. How about that? Let's do that. Okay. All right. So you set the sampling, scan recursively. That would be deeper into the files, and then start sampling randomly. So this is object scans image. Okay, let's see. It'll probably ask me for the URL. Let's go for here. Storage. Because I have several buckets that are already configured. We'll just set this up just to have something to go to. Okay, where is the URL? There we go. Okay. So we would enter this here. Okay. Continue in. Template name. Just gonna use that. All right, you see these info types here? 200 types. Oh, I'd have to have a different template name, but this is just to give you an idea of it. All right, and then you can add actions to filter in or out. So you can save the BigQuery, publish the pub sub, to security command center, you notify by email, or to cloud monitoring, or make a de-identified copy. You'd schedule this to run, specific time span or trigger, and then you look at review, and you see all these here, right? And then click create. So we're going to discard that and move forward. All right, and you can also do this on the command line. I'll show you this. So click gcloud DLP jobs, create inspect, and then display name, my inspection job, inspect config, the inspect JSON, and then the storage config file for the storage JSON. Select the location for global and action save findings. All right. So that'll give you an idea of what to have. Okay. So inspecting and de-identifying PII data. So Cloud DLP's content.deidentify method enables you to identify and transform sensitive data in a single operation. So there's some components of a de-identification request. One, data to inspect. This will be a string or structured data in a content item object. Then you have your inspection configuration. This will be info types to identify, likelihood of thresholds, and then result limits. And then you have a de-identification configuration. So this transformation method applies to the findings. Then two, you have data identification transformation types. There's two primary categories of transformations that are available. Info type transformations, which are applied only to values identified as specific info types and suitable for selective de-identification. Then you have record transformations. These are applied to entire columns or fields in tabular data. And this is useful for comprehensive data transformation. So there's common transformation methods. One, replace config. This substitutes values with specified strings. Two, redact config. This completely removes sensitive values. Then you have character mask config. This replaces characters with a specific mask character. Remember that hash? Crypto hash config. This creates a one-way hash of the value. Then you have date shift config. This shifts dates by a random amount within specified bounds. So de-identifying and tokenizing sensitive data. So Cloud DLP supports both reversible and non-reversible cryptographic methods. For re-identification capability, you need to choose a reversible method. So there's deterministic encryption with AES SIV. This is one of the most secure and reversible methods, right? So this would be advanced encryption standard, AES, synthetic initialization vector mode, SIV. Well, SIVM, but it's SIV. So for the implementations, you would go to Cloud DLP and make sure you have the KMS active, which I believe we do. We did that in an earlier lesson. So if you have a service account, you do that as well. So let's go to IAM. Let's see. Service accounts. Okay. All right. So we're in DLP. Let's go KMS, which we do have keys and key rings. Oops. All right, so it's keys. All right, now with the service accounts. All right, so we got the project, we have the cloud DLP, we have the KMS, we have the service account. And so we're going to take this one, manage permissions, and then grant access. So we would have new, click the service account, admin. So we would add, let's see, DLP, data, big data, data prop, So the service account AI API. Okay, so let's see if there's permission, condition editor. Well, you could add it here programmatically, but don't want to do that. Okay, so let's see, cloud, data plus, dataplex, data flow. So you could create an, all right, so the basic process would be you create the key ring and the key in the cloud KMS, which you've already done. Then you can create and encode an AES key, which you can do when you have that key. Let's go over here and see if we can do that. Let's go to the key ring, send the key, and then that's the version. Okay. Version selected, disable, destroy. That's going to be the key. Let's edit. Let's see permissions. Okay. Let's try. Cannot be inherited. Cannot be inherited. Let's grant access to a new role. Let's see if this works. Data, key, KMS raw, KMS crypto. I'm not finding it. So basically, you'd want to create this key, which we have this key, and then you're basically doing the envelope method, right? So the best way to do it, all right, let's say if you did it from the CLI, which I don't really want to do, right? You would enter the following. So open SSL random out quote AS underscore key dot bin 32. All right, this is what you would have. And then the next would be base 64. So this would be encoded dot AES underscore key dot bin. And this will create and encode the AES key. You have to use one after the other. So I'm going to close that one out. Clear? All right. And then you wrap the key using Cloud KMS, right? This code. So this would be, oops. Okay, so this would be curl, HTTPS, Cloud KMS, and then you project. You see that project ID, you would have to change. And then locations, global, the key rings, and the DLP key ring, you have to get that key ring, right? And your DLP. Then your request, what are you doing? Authorization header, right? Make sure you have the right application token. And then your header for the application JSON, that would be okay. And the plain text for this base key. All right, so this would be, it's relatively simple, but not entirely. All right, and then once you create that, you can send that request with the text to de-identify and then configure the de-identification method, right? And you'd send that to the DLP and create a JSON request for re-identification through the DLP API. All right. Then you have de-identifying data in cloud storage and BigQuery. Let's see if we can go here. Let's open up cloud storage. Let's open up BigQuery. All right. Okay. So to de-identify data in cloud storage, one, ensure you have a cloud storage with bucket with data to de-identify. I have a bucket, but it doesn't have anything to de-identify. So create a destination bucket for de-identified data. And then you create a de-identification job. So using Cloud Console, you could create a job over here. All right. You'd create a job. All right. Over here for your storage type, cloud storage, to read from the source bucket, and then apply this and send it to de-identify and write it to the destination bucket. All right. So you'd enter that here, sample the data, set it up for configuration detecting, add actions. Actions is where it would come in. All right. Then you have de-identification in BigQuery. Now, I have not done this. Let's close this out. So within this, you identify the BigQuery tables containing the sensitive data, right? And I only have one table, but I don't think it has any data. And from here, you would set this up, cloud storage to BigQuery, right? You have your project ID, your data set ID, your table ID, right? And then you use a data flow template. Let's see if I can get this open. All right, so this will give you more information about this, more specifically, right? And this would be able to read the data from BigQuery, apply de-identification, and write it to a new table. And you configure the pipeline inputs, right, over here. That means the input table, output table, inspection template, de-identification template, and then run the pipeline. And then you'd execute this to run the job to process and de-identify the cases or the data in the cases. All right, so what are some DLP use cases? Let's cancel that out. Okay. Cloud DLP can be applied to numerous scenarios to enhance data security and compliance. 1, automatic sensitive data discovery. Continuously scan your Google Cloud environment to identify data that requires protection, helping you make informed decisions about data governance and security. 2, enterprise-wide data classification. Categorize data across your organization, whether cloud-based or on-premises, to ensure appropriate governance and compliance with regulations. 3, secure cloud migration. Before moving data to the cloud, scan and classify sensitive information, then appropriately de-identification transforms to ensure security throughout the migration process. 5, real-time data protection. Implement DLP and data pipelines using Cloud Data Flow or Cloud Data Diffusion or Cloud Data Fusion to tokenize sensitive data before storage in data warehouses. 6, contact center security. Automatically mask PII and customer support chats to prevent agents from accessing sensitive customer information. So what are some best practices for Cloud DLP? So some implementation strategies would be choose the right approach. Use data profiling for broad scanning and inspection jobs for deeper investigation. Leverage built-in rules. Utilize Cloud DLP's extensive library of built-in inspection templates, and then automate DLP scans. Configure event-triggered scans using EventArc API or BigQuery sync listeners. Access control and permissions. 2, 1, the first things you would do, manage your service account permissions. Ensure DLP service accounts have appropriate access to resources. Restrict access before scanning. Limit access to new data until DLP profiling is complete. Implement policy tagging. Create hierarchical policy tags based on DLP findings. So then there's integrations with other services. 3, okay? Publish tags to data catalog. This sends classification results to the catalog for better data governance. Use Security Command Center. Forward your DLP findings to Security Command Center for comprehensive security management. Implement quarantine pipelines. With this, you create separate workflows for handling sensitive data identified during scans. So then there's data exfiltration and VPC service controls. So there's data exfiltration threats, right? Organizations face several threats that can lead to data exfiltration. That would include misconfigured IAM policies. These incorrect permissions enable unauthorized access. Then there's malicious insiders, employees copying data to unauthorized destinations. Then you have compromised code, applications exfiltrating data due to security breaches, and you have unauthorized clients with external access using stolen credentials. With VPC Service Controls, this helps prevent data exfiltration by creating logical security parameters around cloud services. You could do this with service isolation, which protects services and resources from internet access, unauthorized networks, and other Google Cloud resources. You can have a security perimeter, which controls the data movement across perimeter boundaries. And you can use access control. This restricts which services can be accessed within a VPC. And finally, you have VPC Service Controls architecture, right? VPC Service Controls protect across 3 primary network interfaces: Internet to Google Cloud resource, VPC network to Google Cloud Resource, and Google Cloud Resource to resource. All right. So how do you implement VPC service controls? Well, one, you go to the VPC Service Controls page. Oh, no. Let's see. I don't know why that wouldn't let me there. Okay. So we're here at this VPC service. We'll select the project. All right. This is good for, darn. Okay, so let's see if we can switch to the organizational scope. I have to get this for a policy. Okay. So let's see. This is not good for projects that needed an organization. Well, within this, you would create a perimeter, and then within it, you define a unique name, provide an optional description, all right? And then you'd add projects to include in the perimeter, right? From there, you'd restrict which services are subject to the perimeter. And these are all the resources you can see. And then at that point, you'd add the access levels. This would define access levels using an access context manager, right? And then you'd review the configuration and click create. Once you understand this, it becomes a lot simpler to see how a lot of this is built in for you to take control of your environment and manage it effectively. Okay, so let's here. Okay, you would enter this with the CLI. This. Oops. G-Cloud access-context-manager perimeters create my-perimeter, and in the title, my VPC perimeter type regular. The projects, you'd have the project ID, and then restricted services, you see this bigquery.googleapis.com, storage.googleapis.com, right? It's fairly straightforward once you get it. Okay. So key capabilities of this include a dry run mode. You can test policies before enforcement, fine-grained rules. You can configure precise ingress and egress controls, access levels. You can set conditions based on IP addresses and device attributes, and then VPC accessible services. So you can limit which Google APIs can be accessed from within a VPC, right? So you can restrict API access. VPC controls offer multiple methods to restrict API access. You have private Google access, which we talked about earlier. This enables private API access from within a VPC. You have restricted.googleapis.com, which limits access to isolated services using a restricted VIP range. Then you have VPC accessible service, which specifies exactly which APIs can be accessed. Then you have creating service perimeters, right? You do this with the Access Context Manager, which allows administrators to define access control policies based on attributes like user location and source IP address. Then you have access levels, which specify conditions that must be met for a request to be honored. Important rules like ingress only, which would allow access levels only ingress rules. You could use egress policies for outbound access. Then you have interperimeter requests. These would be requests between perimeters that require explicit rules. And then you have IP allow lists, where only public IP ranges can be used in access level allow lists, right? I'm sorry, only IP ranges can be allowed in these. So to do this, let's see if we can implement this. Let's see if we can find this. Web risk. Create an access level. This will be a good tutorial. Okay, we'll get to that. No, web risk isn't going to be it. All right. Is that it? Okay, so you can do this right here with this tutorial. As you'll see, it takes about 5 minutes. So you can do this in a cloud project with IAM, basic level, add an IP subnetwork to your IP, your access level, and you'll be good. But basically, you're going to define the criteria for accessing resources within the perimeter. Then you create a service perimeter. With that, you can specify the resources to protect, assign administrative access, configure VPC accessible services, define access levels, and then set ingress and egress policies, right? And then you'll configure the perimeter security to enable all protected services, set up appropriate firewall rules, and then configure private connectivity. So here's some best practices for VPC service controls. Simplify your perimeter design. Start with a single large perimeter when possible. Use perimeters for data sharing. Create separate perimeters when sharing data with external parties. Enable all protected services. Reduce complexity by enabling all services within a perimeter. Organize projects into folders. Group related projects for better management. Test thoroughly. Use the dry run mode to identify potential issues before enforcement. Then document use cases. Maintain detailed documentation of each access pattern. So to conclude, Cloud DLP provides comprehensive capabilities for identifying, classifying, and protecting sensitive data in Google Cloud environments. By implementing appropriate inspection templates, de-identification methods, and security controls, organizations can significantly reduce the risk of data breaches and compliance violations. VPC Service Controls complements Cloud DLP by preventing data exfiltration, creating secure boundaries around Google Cloud resources. Together, these services perform a powerful foundation for data protection in the cloud. By following the practices outlined earlier, you can effectively implement and identify Cloud DLP and VPC service controls to enhance your organization's security posture and maintain compliance with regulatory requirements. So thank you. And remember, come back again. The next chapter will be Secret Manager. Have a good day.